Actually, it's automatic spray production line. And in last 2 years, it has been tried to modify, it has been modified to spray UHPC. So here's the background. I'm sure you all agree with me. The development of manufacturing GRC is not that ahead of the, let's see, the world. Actually, it's lagging behind the development of other industries. So from 2014, we started to develop the automatic spraying machine and the production line. So, yeah, so as UHPC, I don't know quite well in the world. It's super hot in China. It's very popular. I would think more than 50% of the project originally was designed with GRC and being converted to UHPC. So the UHPC, we have reached a common sense. It's good to make the perforated panel, but for the complicated shape, it's difficult. So then, on the market, they have a sprayed UHPC. So basically, use the same equipment like power sprays and the same fiber from the same glass fiber. And the only thing is the slurry is modified. So in 2015, FTI had proposed the concept of high performance GRC. And since then, seems I haven't heard any new development. So we did a little bit, okay? So what's the difference? Okay, I think it's kind of a gimmick to promote UHPC. For me, I have to be loyal to GRC because it's a GRC Congress. So I call it a high performance GRC. Basically, it's the same thing. That's my personal opinion. Feel free to challenge me or discuss with me. So the key part of this production line is the automatic spray station. So after 6 years, the prototype was tested in 2020. And then in the last years, we modified it, tried to spray this high-performance GRC. Okay, I'm not going to read it. Okay, this is how the spray station works and what it consists of. Here's the specification. So the overall dimension is 18 meter by 5.5 meter and 4.3 meter. So the lateral stroke is 25 meters, vertical 1.5. Oh, longitudinal 16 meters. Yeah, this is the picture of the spray station. Yeah, I like our Cambridge friend. They use a robot to spray it, And we put the, I could see the fiber roving was kept separately. But we placed the fiber roving just above the spray head. The transmission system, it's 5 axes. So it's longitudinal, lateral, vertical, and two rotary. So which means this left, right, and forward, backward. So that's the electrical control system. Okay. And that's some short video clips to spray different shape of the product. Yes, the features that I want, the advantages. Basically, it increases their productivity, and it's better controlled, the quality control. And the material is more uniform. So that's the specification. And then next is the whole production line. It's 100 meters long, 35 meters wide. Consists of 6 working area: mixing, spraying, and static placing, curing. I think that's wrong. Not mold manufacturing, mold conveying. And after the product, surface processing. So the production capacity, if it's equipped with 3 spray stations, so the daily capacity is 400 square meters, and the annual one is 120,000 square meters. So that's the layout, the plan layout of the production line. And that's the 3D one. Okay, here's some real pictures. This one is for the for stacking the mold and unstacking. And this area is the spraying area. The automatic spray station is here. The mold. Okay, this is the flow chart. Again, this is the electrical control system of the whole production line. The cabinet, the control cabinet, can be connected to the network. So it can be, the whole production can be remotely controlled. Batching system. It's slightly different from mixing GRC. Firstly, we dry mix a bulk volume of the dry material using a dry mixer. And then the dried mix, and then the liquid materials are fed into a heavy-duty planetary mixer. Because why it's planetary? Because we know UHPC mix, the viscosity is very high, and a typical high-shear mixer cannot do the job. And also we need the volume. So it's a forced mixer. And by weighing the large volume of dry material, it increases the accuracy and also make the mix more uniform because it makes twice the dried mix. Okay, the flow chart of the batching system. And the slurry conveying system, it's a little bit primitive. So it's an electrical host carried a self-dumping hopper, and it goes on the overhead rails. Okay, that's the mode. Also, the product in the mode, okay? Conveying system. Yeah, the core equipment is the Specification. And it's steam curing. So we made 3 kilns to cure the product. And the steam curing for slurry or mix with fine powders is very important. The inside the kiln. And that's the process, the surface product surface processing. So the dry grinding chamber, water grinding chamber, sand blasting. Yeah, we have some dust collection removal device. A quick talk about the development we did for the high performance GRC. You see, to make it high performance, so the mixed design of the slurry has to be close or similar to UHPC. But the dilemma is, if it's same as UHPC, it's difficult to pump, or maybe impossible, and difficult to spray. Also, if it's vertical or inclined or declined mold surface, so its material flows down. So we need to make a balance, to find the balance. Here's some work we've done. Try to modify the mix. We started from successful mix design, UHPC design, developed by the China Building Material Academy. We start from that design, that formula. And on top of that, we did some work. So we used the nanosilica. It's much finer than silica foam. And it's not a fine particle anymore. It's like an additive to modify the wet mix, the fluidity. Oh yeah, because it's a white mix, so all the raw materials, are light colored. Yes, the mechanical and physical properties. You can see we made some compromise on the compressive strength and water absorption. The density is between the GRC, normal GRC, and UHPC. LOP MOR is quite impressive. Young modulars, a little bit higher than GRC. But the compressive strength, we couldn't achieve 120 megapascal anymore. Water absorption, higher. And for the UHPC, normally it's less than 3%, around 2% for this mix design. But when it's being modified and used for sprayed GRC, sprayed high performance GRC, so the water absorption and the compressive strength is not as good as the original UHPC design. So this is actually the sprayed high performance UHPC GRC. And the video clips I showed before was sprayed. It was not GRC, it's high performance GRC. If you look at the details, the compaction, the spraying, you can see it's a bit different from the conventional GRC. Okay, here's the conclusion. Automatic spray station and production line has been set up to improve the productivity and reduce cost. Some success has been made in the development of HPGRC, both in manufacturing technologies and in physical and mechanical performance. But we have to admit, it's still at the conception stage, and further work needs to be done. Okay, thank you.